After incubation is completed, the plates need to be read, and good light is important when reading the plate. Flexicult vet plates contain a chromogenic substrate, which allows you to identify various urinary tract pathogenic bacteria. The chromogenic substrate makes it possible to establish the enzyme activity in the bacteria. The agar and the colonies will appear in different colors. This enables you to identify various urinary tract pathogenic bacteria. And the growth, or lack of growth of bacteria, indicates which antibiotics can be used for the treatment. It will be advantageous to use the manufacturer's information insert, containing distinct charts and pictures, which are useful for the reading of the plates. Bacteria density is evaluated in the large compartment. Here you can assess the amount of CFU per milliliter contained in the sample. And the growth or no growth of bacteria will show which antibiotics to choose for the treatment of the patient. I will now go through some examples of reading the plate. I'll now have to look at the first example. Here I can see that the bacteria form large red colonies. In the insert, Chart 2, I can see that this corresponds to E. coli. I also assess bacteria density in the large counting compartment to assess the quantity of my sample. In this sample, the density is 10 to the 5th per milliliter. Then I take a look at the 5 antibiotics compartments to see in which compartments there is growth and in which there is no growth. Again, when reading the plates, it's crucial to use the manufacturer's information insert. In this example of E. coli, there are 2 compartments with no growth, indicating that the bacteria are sensitive to this antibiotic, and 3 compartments with growth, indicating that the bacteria are resistant to these. It's important to evaluate bacteria density in the counting compartment and the antibiotics compartment. They must coincide. The type of bacteria I'm looking at now is a Klebsiella species. It forms large, fat, dark blue-purple colonies. I used the pictures from the insert to identify the bacteria species. Again, I assess the bacteria density in my counting compartment and quantify my bacteria. In this case, there are 10 to the 3rd per milliliter. I look at the antibiotics compartment for determination of resistance. Growth indicates that these bacteria are resistant, and here, where there is no growth, they're sensitive. My next bacteria sample is a Proteus vulgaris. It grows with large colonies of a green-brown colour. The agar has taken on colour as well. This is due to the bacteria enzyme activity. You should not interpret it as growth unless colonies are formed in the compartments. This Proteus vulgaris here is resistant to only 1 of the 5 antibiotics on my plate. I can also show an example where you can clearly see the difference in bacteria density. When I look at this plate, the colour tells me that it's an Enterococcus faecalis. But when comparing the bacteria growth on these 2 plates, you can tell that there is a higher bacteria density on one plate compared to the other. On this plate, density shows that there is 10 to the 5th per milliliter. And on the other plate, also with Enterococcus faecalis, density is only 10 to the 3rd per milliliter. Again, by reading the resistance compartments, you can find out which type of antibiotics to treat the bacteria with. These bacteria grow with large greyish-white colonies. Furthermore, there is a metallic sheen to this plate, which is very typical for the bacteria on my plate, which is a Pseudomonas aeruginosa. Furthermore, the agar gives off a sweet smell, which is very typical of Pseudomonas aeruginosa. The reading shows that there isn't a high degree of sensitivity in these bacteria, as there is growth in many of the antibiotics compartments. For the determination of resistance reading, it is crucial to use Chart 3 in the producer's insert. This chart lists various antibiotics towards which this type of bacteria is resistant by nature. And this is a very important reservation to make when reading and interpreting your results. The manufacturer's poster of various bacteria that can be identified on Flexicult Vet clearly shows the various colours we've just examined. Here you can also see some of the other bacteria species we didn't mention in our examples. For instance, Staphylococcus pseudointermedius, which form white rose-coloured colonies. And here you see Faecium, which is somewhat lighter than Fecalis. At the bottom of the poster you see Streptococcus canis, which is a hemolytic streptococcus forming white colonies. Finally, over here you see a picture of a mixed bacteria flora. And mixed bacteria are characterized by two different colours growing in the counting compartment. This indicates the presence of two urinary tract pathogens. This picture shows the red E. coli and the green Enterococcus fecalis. The poster is available from the manufacturer.